Hi, it's Miss Murphy. How you doing? Just found out today that we're going to be going back to school. October 19th, you're going to be in my classroom, or the 20th. But we're going to keep doing mini lecture videos. Probably, we'll see. You like my coffee cup? I use this mug periodically. Like a student gave me that. Those are my favorite coffee cups, my chemistry coffee cups. Okay, so today I say the same thing. This is going to be really easy. It's actually going to be really short and pretty easy. We're going to look at the topic 2.5 or 6.5, metals, alloys and metals. So I don't have too much to say at all. I'll be quite honest with you. It's definitely not any of a favorite topic of mine. You know, I don't find it very interesting or fun at all. So I apologize if I don't bring a lot of enthusiasm to this lesson, but I'm going to try. I'm going to try so hard. 2.4, metals and alloys. So basically, guys, I think we talked about, I don't know if we talked about alloy. Alloy is just a mixture of metals, okay? It's a mixture of metals. Simple as that. And there's two types, okay? You have to know the difference of the two types. You see it right here. They're written out for you, substitutional and interstitial. And you can visually see the difference. In the substitutional, you see that we have metals of similar atomic radii. Metals with similar atomic radii. Okay. And in the similar atomic radii, so that one is just substituted in place of the other, right? You can't see, but I think you see, you can see that. I'm trying to draw on there, but you can't see that because it's black. That's okay. So what we have is where this atom here and this atom here is substituting the place of another atom with a similar atomic radii. And what we have is this atom here and this atom here are taking up the places inside, right, of the larger atoms. So we call those interstitial, and that's what we have when we have metals with pretty different, right, pretty different atomic radii, okay? And, you know, so why do they make metals or alloys out of metals? Why would they mix? Why would someone want to mix metals? Well, we can look at some basic properties here. And in almost every one, you're going to see that it makes it hard. So it makes these structures harder, right? And metals are used a lot in infrastructure, right? Think about in buildings and bridges. So you're going to want to use those alloys. You can minimize the amount of rusting or oxidation that occurs by using alloys. You can increase the strength by using alloys. So you see this alloy here of bronze is hard and strong. It doesn't corrode easily. It's shiny, right? You may want those qualities. And so these are the properties of this sort of alloy. Brass is copper and zinc, mostly copper, but the brass itself is going to be harder than copper. So once again, we see hard and hard. We see that bronze is in statues, monuments. That would be because it doesn't corrode easily. So this is the type of like material science. What materials should we use? We want to think about what properties those materials have. Once again, you see hard and strong. That's your steel, right? Stainless steel doesn't rust. It's shiny. All these great qualities, because if it's a metal and you're going to leave it outside, well, you want to make sure it doesn't rust, right? And that's another word for oxidizing. So strong. So, that's why we're going to, why anyone would take the time to heat these metals to really high temperatures and from there to mix them. Okay, so that's really about it, guys. I would say that this interstitial, I would imagine, would be less malleable, right? It would be harder to bend because those atoms are in those spaces right there, making it harder for one atom to pass over another. So I would say that can't think of any other question I've ever seen on alloys. You just don't see much, but you'll see, as the interstitial substitution, I'll try to give you confusing diagrams. When I say they, I'm referencing AP Central, just trying to, and that's it. Okay, so I'm going to go ahead and end this meeting there. I did tell you this would be one of the shorter ones. So stop share and